Good morning. Well, I would like to ask Professor Luface, the first promoter, to begin this examination.
Dank u wel, meneer de voorzitter. Thank you, Mr. Chairman. Geachte promovendus, dear doctoral candidate, could you explain, please, to the committee and to the general public in about 10 minutes about the essence of the research you have been doing?
Hooggeachte promotor, a very pleasant day to all. It was almost 5 years and 2 months back, the day that I received a piece of zipper from my supervision team with a mission to make it move without changing anything, a mission that motivates me to develop Cliff, an automatized zipper, which I will share with all of you today. Next slide. The inspiration to develop Cliff came from the zipper bot developed by Adam Witten from MIT. The zipper bot did not use the slider of the zipper to zip or unzip. It is not a generic type of an automatized zipper. Therefore, we challenge ourselves to develop a generic and universal piece of it. The number of elderly populations around the world is increasing. We designed Cliff to be an assistive device to assist the elderly and people who has problems using zipper. Moreover, zippers are everywhere in a big and well-established zipper and fashion industry all over the world with no signs of decline. This motivates us to keep going with this project. Next slide. We line up 4 central research goals. First, we aim to visualize the evolution trend of the zipper design since its first invention. Secondly, can we develop a generic kind of an automatized zipper, and what are the essential factors to produce efficient traction mechanism and components needed? Third, to look for the critical factors to design and develop Cliff to ensure user could positively perceive and use it. Lastly, to find out whether the iterative research through design approach can help us in the miniaturization of Cliff. Next slide. This project follows the research through design approach. The literature review focused on the zipper structure and zipper bot's invention, while the pattern review to visualize the design evolution. To understand the physics and mechanics on how to move the zipper, we use Meccano. Then we did a force measurement and analysis. We performed 2 iterations to miniaturize Cliff. Then we conducted a user study to assess the wearability. We then conducted the root conflict analysis of Tree's method to solve the technical contradictions before we developed the 4th iteration design. Another user study was conducted to evaluate the wearability, perceived usefulness, perceived ease of use, credibility and expectancy of Cliff. We reflect to the feedback received by developing the 5th design, which was selected for the Dutch and Dubai Design Week 2018. We perform an exhibition study during both exhibitions. Next slide. We reviewed 940 approved patent reports published from 1840 to 2017 related to the zipper term and cooperative patent classification CPC of A44B for buttons, pins, buckles, and slide fasteners. We found that the design of the zipper slider has evolved from the conventional type to the removable, rollable, adjustable, and towards developing an automatic slider or even robotic zipper. It proved the existence of some efforts in designing a new kind of the zipper which is aligned with our design intention. Next slide. To explore the potential traction mechanism, we use Meccano. We found that the gear teeth grab the zipper tape in between the top and bottom wheels. We then analyzed the forces acting to the system to determine the amount of speed and torque needed to miniaturize Cliff. Important findings here are sufficient normal forces is crucial, friction is essential to produce good traction, and the slider should sufficiently fix to avoid misalignment. We also need to ensure the height of fixed point to be low to avoid the bending problem of the zipper tape. Next slide. The development of cliff then enters the miniaturization stage. We design the second iteration like a detachable piece, which offers flexibility. We use a metal clip to provide the normal force. Then we build the third iteration, which is a complete unit of cliff with the battery and switch attached on it. However, we discovered the problem on the third iteration as the side transmission gears are too small, not strong enough to be operated. We managed to miniaturize cliff by a factor of 3. Next slide. Then we conducted a user study with 22 elderly in the Netherlands to evaluate the acceptance of cliff using a wearability assessment tool. The elderly told us their common problems while using the zipper. They experienced the second and third iteration prototype before answering the wearability assessment questionnaire. We found that the acceptance of cliff is satisfactory. We discovered some important issues such as the stigmatization and product semiotics, which need to be considered in the next design iteration. The elderly thinks that cliff is a potential device for them, but it's still bulky. Next slide. In order to solve the technical contradiction in the third iteration prototype, we use TRIS method. We approach the problem systematically by performing the root conflict analysis, then select the technical contradictions, apply the Alsuher matrix, and apply the inventive principles triggered. From a total of 26 inventive principles triggered, we found that 9 of it has a high chance to be further analyzed to improve our design, which are shown here. Next slide. Based on the inventive principles triggered, we continue to improve cliff and develop this fourth iteration prototype. For instance, we use the taking out principle to remove the side gearbox and directly connect the DC motor to the rotating wheels. We also introduced the permanent magnet to replace the metal clip based on the principle of replacing the mechanical system. The spheroidality curvature principle helps us to improve the boxy looks, which is now a more smooth and curvy shape. Next slide. Using the fourth iteration prototype, we conducted another study with 72 Malaysian elderly to assess the wearability, perceived usefulness, perceived ease of use, credibility, and expectancy of cliff. We also performed a session to study the preferable shape, colors, features, and the control method. The elderly see cliff as an unknown device, but they impressed with the looks of it. They found that cliff is an effective and useful device to assist them using the zipper. Their concern is more on the physical factors such as weight, size, width distribution, and to improve aesthetics of cliff. Next slide. With the aim to connect cliff to society and improving the looks, we developed the fifth iteration prototype. Cliff was selected for the Dutch and Dubai Design Week 2018. We decided to design a dedicated garment, the yellow sublimation dress, in a close collaboration with BuyWire.net. This version of cliff cannot run without this dress. We use a conductive zipper tape connected to the LiPo battery to transfer the power to cliff using a battery connector. We hide the LiPo battery and the switch in a little pocket at the back of the dress. Next slide. During the Dutch and Dubai Design Week 2018, we performed an exhibition study. 86 visitors volunteered to participate. We found that the participants agreed that the new look of cliff is beautiful, complete, less complicated, and more aesthetically pleasing. The visitors also mentioned that cliff is not only beneficial for the elderly, but also to people with finger dexterity, hand disability, and single mother who lives alone. According to them, cliff has a huge potential for the industrial application. Next slide. Based on our findings, we list out the answer to the research questions formulated. First, we found that the zipper design evolved from the conventional type to the removable, rollable, adjustable, and towards the automatic zipper. Secondly, yes, we managed to develop a generic version of an automatized zipper. Essential factors for efficient traction mechanism are friction, normal force, and friction coefficient. Third, the elderly believe that cliff is an effective, useful, and could reduce their difficulty. Some important issues are the product aesthetics and semiotics, stigmatization, and the attachment method. Lastly, the iterative research through design is helpful, which will learn something new from different iterations, especially to reduce the size, improve the performance, and the looks. Next slide. At the end of this journey, we realized that the project is in fact more ambitious than we thought initially. We had to work in 3 different worlds, which are the mechanical engineering, user research, and fashion. We often felt ourselves to be in between these 3 different fields. The blend of these 3 fields are the recipe of cliff research success. Next slide. The work conducted is not without limitations. Listed here are the options for future work, which includes the use of the right angle DC motor, which might help to improve the overall design. Secondly, to embed additional features on Cliff, such as localization and the touch switch as the control method. Next, to explore Cliff with people with disability. Lastly, to see how Cliff could be brought to the market and used for the other potential applications, such as on the dust barrier system. Next slide. As the zipper goes up to zip, when down to unzip, the same thing goes in my life. There are ups and downs for the past 5 years while I'm doing this research. Losing the loved one, my parents and my father-in-law is among the toughest moments for me, but there are also great moments happen. Winning 4 Best Presentation Awards and selected for the Dutch and Dubai Design Week 2018 are the achievements that I am proud of. I'm grateful to have such a great supervision team and colleagues around in TUE. I always believe whatever it is, life must goes on, and that belief brings me here today. Thank you.